So what we're going to do today is just some exercises. I've got two of them lined up here, and we're going to do some exercises in PHP. There is one thing that I'm going to cover at the end, like maybe on Tuesday, PHP classes in PHP, but it's not that essential because we're going to start on object-oriented programming, but we're going to start on object-oriented programming in the context of Java. So I'll talk briefly about how to do classes in PHP, but you're not going to use them. So what I'd like to do instead is to apply that lecture to reminders about how to build and design objects, classes in Java instead, and to recover all the tips and tricks in your IDEs and Eclipse that you can use to design this stuff and do the boilerplate kind of stuff for you. So the first exercise, a lot of you are going to be familiar with it because you did it last semester. Some of you didn't do it last semester. Some of you took the other section. But it's DNA translation. So for that, I'm just going to go to our hack here. DNA, of course, deoxyribonucleic acid. Deoxyribonucleic acid is a molecule that encodes genetic information. Somebody asked me, I'm not a biologist, so somebody asked me last semester anonymously, I forget what show it was, DNA is actually a double helix. So what happens is it gets it gets unfurled or whatever the technical term for that is, and then of course you've got two strands. Each of the strands is complements of each other. So adenine, thymine, cytosine, and guanine, right? AGCT, all right? And they're complements of each other. So if it's adenine over here, it's going to be thymine. No biologists in here either, all right? Whatever the opposite is over here, and vice versa. So which one of them actually gets translated into proteins? I don't know. Apparently there are codons or whatever on the strands of DNA that says this one gets translated and that one gets ignored, or that one is used in another process or something like that. The exercise we're going to do is a simplified version of that. That if you're given a DNA string, for example, down here, AA, TT, C, G, blah, 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 the rest of it, then what you do is you translate that into RNA first. So for RNA translation, the thymine, the T's get changed into U's, into uracil. Then once you've got that RNA string, then you go by what are called trigrams. So you take the first three characters, then the next three characters, then the next three characters, and each one of those has a direct mapping back to, I'm going to have to go, over here. Now, here's where it is. We actually gave this part to the students last semester where we did that last translation for you. That if you're given AAA, that translates to this protein K over here. I don't know what the protein is called. But of course, if you've got 4 DNA bases, trigrams, that's going to be 4 times 4 times 4, 64 possibilities. There are only 20 there are only 20 proteins. So some of these get repeated. For example, CCG and CCU, in fact, all of these map to the same protein, whatever P happens to be, right? And there is also some stopping sequences, I think, right? What is the stopping sequence? Fine, X. Yeah, there are 3 stopping sequences that it'll translate these trigrams into proteins until it sees one of these, and that's where it stops. Okay, so that's the basic idea. What we want to do is we want to take a text file containing a bunch of DNA. We want to read in that text file, ignoring all white space, because typically DNA is very, very large, so you can't have one file with one big giant 3 megabyte line. So you go down and you cut it off, and you have multiple lines. Maybe sometimes it's indented or something like that. We'll just ignore all white space. Once we get this big giant DNA string, then we'll go ahead and turn it into RNA by changing all the T's to U's. Once we've got our RNA, then we'll go trigram by trigram by trigram and use this mapping here to output each one of these proteins. Okay? Any questions on the process itself? No? All right then, let's do it. So, not hello world. We'll start from scratch here. First of all, to make sure that this actually works, let's give ourselves some DNA to work with here. And I'll just go AAA, CCC, GTA, GADA, give me your favorite DNA string. TCT. GTA. There we go. All right. And I want to make sure that I've got multiple lines here. So what I'm going to do is I'm going to repeat, 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 and then let's go through and mutate A, G, T, T, or G, 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 T, T, A, right? So different lengths, etc. We can even break one up for there. We can break that one there. Maybe put in a blank line or whatever. So not corrupted DNA, but corrupted representation of DNA. Okay. So there's my input file. First step, we need to open up that file and start reading it, line by line. Or in PHP, is there a more convenient way of doing this?
Just go through the whole thing.
DNA. Well, what do you mean? What do you mean go through the whole? I could go through the whole thing line by line, concatenate it all together, or I could do it in a one-liner. File, get contents of DNA.txt. Right. Now, there's no debugger here, at least not as it's set up like this. I'm sure that there's some debuggers out there for PHP. I'm just going to go ahead and print it, printf, so I'm going to revert back to poor man's debugging. Right? DNA, and let's make sure that this actually works. And it did. There's the file, right? It's the same thing as over here, right? Next step. Translate the DNA to RNA. So what am I going to do there? I'll want to replace all single character T's, thymine, with uracil, thymine. Yeah, it's thymine. So how do I replace T's with U's? I don't know. How would I go about finding this answer? PHP, replace character. I think there's going to be a preg replace, or str replace will work too. Stay away from W3C schools like the plague. The actual real documentation is always going to be at php.net. So there's the thing I'm searching for, or is it? Replace all occurrences of the search string with the replacement string. So their occurrences, replace it with this. In this, in subject is replaced with a given replace value. So let's test it out. str replace. I want to replace all thymine with uracil in DNA. Now, is it going to return a value? I forget. Does it have a return value? This function returns a string or an array with the replaced values. Okay, I don't know what that means. Let's find out. We'll print DNA. Did it change the original DNA or not? Remember, in Java, it's not an option because strings are irreplaceable, are immutable, right? So you can't change them. But in PHP, you can change them. So I have this question here. Is it going to change the string that I give it? Another way that you could look at that is, look at this. Is it going to change the string that I give it? Is that passed by reference or passed by value? It's passed by value, right? So is it going to change anything? Nope. And it did it. I'm outputting DNA over here. Let's output RNA and see which one is the one that's replaced. RNA is replaced. DNA is left alone. Okay. That seems kind of unsatisfying. What am I going to have to do ultimately to, if I've got spaces in here? There's a space. There's a tab. Right? Tab over. Right? I don't want to translate spaces into proteins. That's not something that exists. So what else should I replace here? Get rid of white space. Does anybody remember how to do that? Preg replace. You're going to have to help me because I don't remember, honestly. Preg replace. PHP net. Drag replace. And white. Come on. White space. Oh, hey. There it is. Ignore that for now. All right, so I can go immediately and get one of those common solutions. RNA, you can translate it before or after if you want to. I'll just go ahead and translate the RNA so that it strips out all the white space there. Okay. And I don't care about the DNA anymore. Let's make sure that we've got this. Oops, what's wrong? Where?
Line 5.
Fine. Oh, thank you. There we go. All right. Did it work? Nope. So what does this do?
I think you need to not replace them with just spaces.
Well, actually, don't. Yeah. Here's one lesson: don't blindly just copy pasta something that you read on a website. It strips excess white space from a string. That's not all white space. This is a white space character followed by one or more white space characters. And then you could, if you read the example here, it'll output this. Yeah. Okay. Anyway, the real solution here is just one of those things. This is one or more white space characters, and replace it with one space character. No, with no space characters. Right, there we go. And of course, it's printing on multiple lines just because it's if I give it more space here, of course it shows that it's one line. So there's only one string here. Okay. That's RNA. All right. Now, how could I get it so that there were trigrams? The first three, then the next three, then the next three. I could do something like this, a traditional for loop, for I starting at 0. I is less than the length of the string. How did we do the length of the string? Do you remember? It's count of the RNA string, I++. And is that going to work, by the way? All right, what did I do? I'm not doing anything now, but it's going to complain about this. Why? It's expecting a parenthesis here. What did I do? I forgot the $sign. What is it going to try to interpret that as? Something without a $sign is not a variable, but it is an identifier. It is a global constant, right? Like m sub pi. Right? That is without a $sign, and so you can get that from the math library. But all variables have to begin with a $sign in PHP. Right? I can get those three characters, so I could say that the first one, A, is equal to RNA, and you can treat strings just like in C. You can treat them as a zero-indexed array, so I can go with I, and then the second one is B and C. I could get all three of these things if I really wanted to, and I plus 1, I plus 3, or 2, there we go. Except that if I'm going to go get these three, these three, these three, how should I increment my I? Instead of just 1, 1, 1, I should, if I get these three, I want to jump to the next three. So I plus 3, and there's a shortcut way of doing that that's supported in PHP and a lot of programming languages, plus equals. All right, that'll work, and I could call it this trigram, and I can go ahead and concatenate these all together, A plus B plus C, right? And then let's print it out, print %s and the line, trigram. Thank you. $sign, $sign. Oops, $sign. There we go. And run that. Oops. Thank you. You guys know and beat PHP better than me. There we go. And still on 17. Thank you. There we go. Still a warning. Count parameter must be an array or an object. So not count. str. Well, there you go. It's C inspired. str. len. There we go. That looks good to me. AAA, CCC, GUA, or yeah, good because the T has been translated into Uracil, and then AGA. Yep, that looks good to me. What is the last one correct? UAG. Oh, nope, because it's not divisible by 3. And that's why we're getting an initial that we're out of the scope here. I was trying to count and make sure that they were all 3s, but let's go ahead and add one more. There we go. And run that again. There we go. UAG is going to be the last one because that T has been translated to Uracil. Okay, good. All right, good so far. Is there a, that looks kind of ugly though. Is there a better way? PHP, yeah.
You can do a string split.
Oh, string split. Yeah, so you skipped a step. I was going to suggest PHP substring and read all about substringing stuff, right? Not W3C schools. All right, substring. You can return a portion of the string at the start with a given length. So what we could have done is starting at I, and what was it called? Sub str, starting at RNA, starting at I, and then of length 3. That gives me the trigram right there. All right. Your suggestion though is go full bore here, and what was it? String split.
It's just str underscore split.
Str split converts a string into an array. But let's see. Convert a string into an array. Oh, the string is an array, but a string of substrings. So let's yeah, this is the limit though. Split length right there. That's the optional argument. So here's my string. There's a nice little optional argument here that if that, but the default here is 1. So the behavior is going to be that it's going to split it all in 1s. But if you provide, say, 2, like this or 3, like this example, it's exactly the example that we're going to want, then it splits it into trigrams. Right? So forget all that. Str split of, what was it, RNA and 3. And then here's trigrams is equal to this. And let's make sure that it worked. Print in a readable fashion trigrams. And run this, and there we go. AA, CC, Kua, Aga, et cetera, all the way down. And now I can iterate over those trigrams instead. For I running from 0, I is less than count of trigrams, right? Blah, blah, blah. Traditional for loop. Is there a better way? A more idiomatic PHP way of doing this? For each. Right? And I can do a full for each here, but I don't care about the indices. I just want the values. I don't care about the keys. I just want the values. For each, I think it's a or trigram in trigrams as, and then I'll call it a trigram, right? Because that's what it is. Right. Print f %s and the line. Make sure that this works. Trigram, and I'll get the same thing. There we go. So now instead of printing it, I want to map it to an actual protein over here. Okay. So I'm going to want this protein map. And I can, in PHP, I can treat it as a map, right? I can say that here's RNA to protein is going to be an array. And this is not correct syntax, but what would be correct syntax is this thing is going to map to that thing using that syntax. So bear with me here while I, retype everything. Bear with me. Are you going to bear with me?
No.
No. Okay. Then let's go over to a better IDE. And this is what I was showing today. Now this is Java, so it's obviously not going to be the same thing. But I want to bring to your attention a nice tool that is in most IDEs. I don't know how to do it in REPL, if it's even possible to do it in REPL. But you can do it in Eclipse. You can do it in Atom with a plugin. You can do a whole bunch of things. What I want to do here is I want to go in block selection mode. And I want to change all of that stuff to, well, nothing. I want to change all of those commas to arrows. Come on. There. I'm making it recompile every single time. All right. There's a superfluous space there. I'm not going to care too much about that. Oh, you know what? I don't want to retype all those commas. I'll just go ahead and get rid of all of those. There we go. Go out of block selection mode. I've got everything formatted how I want now. And copy paste that. And you can go through and align it, but if you're in an IDE anyway, there's going to be auto formatters, right? If I'm over here and it's not going to work here because it's not compiling, but Control Shift Command F would auto reformat. Oh, wow, it tried to reformat everything as one line. Undo, right? And we'll go ahead and put Eclipse away for now. Right? And then I of course need to make sure that there we go, close it out. Make sure that this runs, and yeah, it runs fine. Right? And the only reason that I'm able to do this in PHP is because PHP doesn't have an array. Arrays, it has associative arrays. You can map numbers, integers, I should say, and strings to anything else that you want. In this case, I'm mapping strings to strings. Remember, there's no difference between single quotes and double quotes. If you wanted to be consistent about it, of course, you go back to your block selection mode and change everything around to double quotes instead. Okay. Okay. In fact, you should. These should be double quotes, or everything should be a single quote or something like that. I want to get the protein associated with this trigram. All I need to do is index it that way. So RNA to protein of that trigram. That trigram is going to be one of those one of these strings. The string is being used as an index, right? And that is the protein. Protein. There we go. Once I've got the protein, you can print it out. Printf. %s and the line, or I won't end the line. And then protein. There we go. Let's see if this works. Come on. I print something. Oh, I don't want to print this anymore. Get rid of that. And there. That's the string. So K, P, V, R, and then of course if we are actually going into a while loop here, if I ever hit an X, you stop. Most of your DNA is junk, by the way, if you didn't know that. It is millions of years of garbage that's accumulated, and it's you don't need it. But the vast majority of it is a lot of it is repetition, but a lot of it is just dormant genes. Right? So, is this correct? What was it? What was the file here? AAA and then CCC. Let's just make sure that those work. AAA goes to K. CCC goes to P. Right. Looks like it's working to me. What was the last one? Tag. So it would be UAC. Or UAG. Was it? UAG. Sorry. Tag. UAG. 54. Yep. Oh, then it didn't work. UAG. Oh, the last one. Thank you. Right there. There we go. Right. So I'm kind of convinced that it works, but of course you'd want to make a full rigorous test case. Yeah.
Is there a way to kick yourself out of the for each loop?
Yep. Let's try that. So let's make it proper, and if it hits an X, let's kick it out. If protein is equal to X, right? Bad, but that's how you do it in PHP. In fact, if you want to do it slightly, so this is bad in general because in other programming languages like C, Java, you're comparing string addresses and it will never work. This will work. What's something that will work slightly better? That's the ultimate. Slightly better. That's much better. 3 equals will be slightly better because now if one of them is not a string, then it won't be true. Now even slightly better. Now what's even better? strcmp of those two things. And if that's equal to 0, and I think that there is a guarantee that that's going to be an integer. There's no mixed types there. If it's 0, then we need to get out of this for loop. How do you get out of a loop? Break. All right. There we go. This is the one time I would say break is okay here because you're using a for each loop. If you weren't using a for each loop, then I mean, if this were a language that I didn't have a for each loop, or if I used something else like a while loop, I'd put that into the while condition instead, and not have to rely on a break to break out of it. All right. Was that correct? Was there an X there before?
Yeah.
Okay. All right, break. All right, were you satisfied with that one? If you want it, I'll put it in the notes. These are going to be in perpetuity, though, because they'll be in GitHub, but that's all right. I've done this before. I'm sure that there's a solution out there. All right. Another one, break my password. Now, I did do the Java version on the video series, so if you want to check that out and see how I do it in Java, go ahead and watch that video. In fact, I think that I also show you a nice use of Maven, but you do not want to use Maven for your projects in this course. I mean, you can, but you'll have to build it differently. So follow the instructions. Don't. But Maven is a dependency management system where you need to bring in an outside library. Right? So what you can do is you can set up this Maven file that says, I have a dependency on this library. It automatically goes out and downloads it for you, brings it in. And what if this library has a dependency on 5 other libraries? And one of those libraries has another dependency on another library. Instead of going out and getting each one of those and trying it, it doesn't work because it depends on this library. Okay, go get that library. Well, that library depends on this library. And a whole transitive graph of dependencies, Maven takes care of all that for you. It's a dependency management system. So that if I want this one library, it goes out and gets all the dependencies, brings them into my project automatically for me. That's in the video. PHP might have management systems like that. I don't know. But we won't need it for this exercise. Passwords are often stored as hashed strings, one-way hashes. Your password is never stored. Your password should never be stored plain text on any system. If you ever in a system where the password recovery mechanism is hit this button and we'll send you the password, get out of that system immediately because they're storing your passwords plain text. Even the system that is storing your passwords mathematically should not be able to recover your passwords, right? Because it's a hash. It is a one-way function. Many of you are taking 235 right now. Functions can be on-to, one-to-one. Hash functions are not one-to-one. By their very nature, they take a large domain, perhaps an infinite domain, and map it down onto a smaller domain, a finite domain. You cannot, I mean, you might be able to have an on-to function, but you certainly don't have one-to-one functions. 2 passwords can map to the same hash. That's possible. It's called a collision. In fact, that's a canary in the coal mine as far as your hash functions go, because if anybody discovers that, then that means change your hash functions, because now it's computationally feasible to find collisions. So the way that it works is you give the password, they hash it. So here's my password. This might be my password here. No, this is the password that you've got to break, that we're going to break. There's a password hasher called SHA-1. SHA-1 is now completely broken, and you should not be using it. But this is just an exercise, so it's okay that I've used it here because my password's not secure anywhere. I tell you that it's from the dictionary. It's a dictionary password. But SHA-1 is a hash function that if you give it the string password, it spits out this hexadecimal value right here. That's what's stored on a system. So when you come in and you want to log in, you provide the password. They don't check the password against the hash. They rehash the password and see, did I get the same thing? Then with very high probability, you provided the password that was originally provided. With a very low probability, you found a different password that worked just as well, right? That's not going to happen. I mean, that's just by random chance. That it's infinitesimally small. Incidentally, hashes are how Bitcoin works. Finding hashes with particular values, like 5 leading zeros or something like that. So breaking these things requires computational time, right? It's brute forcing it. You try this password, then you try that password, then you try that password. Suppose that we attacked a website and we're able to recover this hashed password here. We do know that it was hashed by SHA-1, and we'll just do it with this is called a dictionary attack for a reason, because what's the most common password? Password. What's the second most common password? 1, 2, 3, 4, or 1, 2, 3, 4, 5, and then whatever the minimum is to get to the minimum length password. And variations of that, you can download files with the 10,000 most common passwords in practice, and you can build what are called rainbow tables. Pre-hash everything, sort it, and now all you need to do is a binary search instead of rehashing stuff. So you can invest some time up front, hash 1 billion passwords, and then see if that matches anything. Right? What we're going to do is we're going to kind of build that rainbow table. What we're going to do is we're going to go through this dictionary, we're going to pull out each word, and we're going to hash it. And then we're going to compare that hash to this one that we stole off of that website. And if we find a match, then we'll output that their password must have been this. I'm not working backwards because it's not invertible. It's not one-to-one. 2 passwords can map to the same thing. So if I start over here, it is mathematically impossible that I can reverse this. Right? So, but what is possible is that I try every single possibility, and do I find one that also hashes to the same thing. Right? So there is a dictionary available on the CSE command line. Okay. All right. So let's copy it. SCP. I'm just going to bring it onto my computer here. User. Oops. That's not what I wanted. SCP. This is on CSE. So cut, paste this one. It's an American dictionary. I think there are like 300,000 words in there. I'll put it on my desktop. Come on. Oh, man. Anybody experiencing load on CSE? Okay. Oh, no. No such file? Oh, let's see. There we go. Not relative, absolute. There we go. All right, let's check this dictionary out. The American Dictionary. So lots of words here, not necessarily like everyday words. Ablation, that's an everyday word. Abuse, acceleratory, etc., etc. So word count line on the American Dictionary. There are 305,000 possible dictionary words. And I'm guaranteeing you that one of these words matches this hash right here. Okay. So what we're going to do is we're going to brute force this and see which one of those words and what's my password. Honestly, I have no idea what it was. This is from a while ago, so it's going to be a surprise to me as well. Hopefully, it's appropriate. I'm sure that it's appropriate. So, unfortunately, am I going to be able to do this in REPL? I'm thinking. Oops. That's not what I wanted. There we go. Not Siri either. Can I add file? Can I upload? American dictionary. I'll just do that. Can I open in? Yeah, I'm gonna have to. Well, this is a web browser kind of thing. There we go. All right. Aha. Why? Why is it copying the lines? Oh no, those aren't okay. Those aren't like those. That's the website there copying lines. So all the way down to Ubermenches. There we go. Oh wait, no. Are those lines? Okay, good. All right, we're good. Oh wow, I'm really proud that it was able to handle 300,000 lines. Very, very good, REPL. All right. Also, what I'm going to want is that original hash as a string. All right, so hash is equal to this string here. And you can quickly type that out if you really want to. Otherwise, you just follow along, and when I post this, eventually you'll have it anyway. So I want to open up this American dictionary. Now I do want to maybe do it line by line, or if I could do the same trick and get it all with one line, and then tokenize it and go with each line. What do you want to do? Do you want to go line by line, or do you want to read it all in at once and then chop it up according to the end line characters? Line by line? Okay. All right. Here's a file handle. It's just like C. Open the American dictionary for reading. Right? While you've not reached the file end of file for the handle, I can get a single line. How do I get a single line in C? Forgets, right? And capture that in a line. Forgets in H. There we go. And I can print that out and make sure that it works, right? Print F, %S, and the line. There we go. And I can see, stop. I'm convinced. Except what, Batwoman, Batwoman and Batwomen are both American words. Okay. What does that tell me? Since it's double spacing here, what does that tell me about whether or not forgets retains or chomps out that end line character? It retains. So we need to chomp it out. I can trim it. Or I can str replace all over the place for white space, just like we did last time. Right? But in this case, I'm assured that there probably, I mean, even if there are like Batwomen and there was a a space in between, then maybe I want that because that's part of the dictionary, right? Okay, run this again, and you can see that, yeah, it's chomping all that stuff out. Stop. I'm really throwing the dice here on whether or not I can stop, and it's acting really well today. Good. So I've got that line. What I need to do now is I need to hash it. This is built in to PHP. Whereas in, say, Java, I would have to bring in an external library. The one I do in the video, I think, is Bouncy Castle. They've got a bunch of cryptographic algorithms and stuff like that, and cryptography that you can use. With this one, unfortunately, it's built into PHP. I say unfortunately because you'll see a lot of legacy systems that don't even use, SHA-1 is completely broken, and a lot of legacy systems use MD5. And the reason that they use the MD5 is because PHP built it in, and so it was the easiest thing for people who didn't really understand cryptography to go ahead and use MD5. SHA-1 is not much better because it's broken, but also none of this stuff was really designed for password hashing. Instead, what you want to do is use a password hashing function. Not just, this is called a primitive in cryptography. What you want to do is you want to slow an attacker down. If an attacker can hash 1 million passwords a second, what you want to do is you want to force him to perform 10 million hashes per second. Or not per second, but 10 million hashes. The way that you can do that is, I'm not going to just hash it once. I'll hash it twice, thrice, 4 times. I'll hash it 10,000 times. And now, when somebody tries to hash that password, I'll even advertise it. This is I hashed this 10,000 times. Now it's going to take 10,000 times as much computation power and time to try to break each password. So you're slowing an attacker down. This is one instance in which you want to slow a program down. Yeah. That's another. That protects you against pre-computed rainbow tables. You can salt it and you can pepper it. So assault is, here's their password. And assault, S-A-L-T, not assault, but assault is something that you put at the end or at the beginning. You concatenate like 1, 2, 3, 4 to every single password. That way, if they've got pre-computed rainbow tables and you've got a unique salt, then all their pre-computed rainbow tables are useless. They'll have to recompute all of them. A pepper is used system-wide, so it's like a salt and a pepper. And so you use a salt, 1 per user, a unique 1 per user, and you can change it every single time they log in too. so that if they attack and get all your passwords on Monday, and everybody logs in on Tuesday, all the salts are changed, then you're safe on Wednesday. But you can use a pepper throughout, and so lots of different ways to slow people down: salts, peppers, and making sure that that you do many rounds. And the way of doing this is either bcrypt does this or PBK DF2, password-based key derivation function version 2. Yeah.
So even if SHA-1 is broken, can you still use it a ton of times? That's better than none.
It's better than nothing, certainly, but it's still not best practice. SHA-1 can be used for, and in fact, up until a year ago or so, it was used for, and it can still be used for file integrity. So you checksum. You download a file, and they also publish the SHA-1. Did you download the correct file, or did somebody change the file and put some malicious code into it, and now the hash no longer maps? You know that the file was tampered with. Or if it's just being sent over the wire, how do you know that you sent 5 zeros and you received 5 zeros, and you received 5 ones? How do you know that that there's an error there? You use a checksum, or you use a file check, and you can use it in SHA-1 for that. But the reason GitHub, or Git entirely, I think, went away from SHA-1 is because collisions were starting to be discovered. You could create 2 different PDF files that had the same SHA, and somebody, there's a nice little blog story about this on the internet. Somebody thought, oh, cool, you can do that? Let me go ahead and check that into a GitHub repo. And because he had 2 different things with the same hash, I think it kind of corrupted his entire GitHub repo. And he did it on a production system that wasn't his, and got in trouble for it. Hopefully he got in trouble for it. Don't run experiments like that on production level systems. Just create a hello world GitHub repo and see if you can break anything. But that's why they moved on to SHA-2. And there is also SHA-3. SHA-3 is Ketchek, but it's not in wide use yet, even though it's like almost 10 years old now, I think. But there are plenty of hash functions out there. Any other questions? Yeah.
What's the difference between 256 and 512 for SHA?
That's SHA-2. They just have different modes on the length of the hash value. And I think that there are other modes too, like you can get it down to 128, but no, don't use that. Only for non-cryptographic applications. And then Ketchek, SHA-3 has an arbitrary, it's a sponge construction, so it soaks up the entropy, and then you can squeeze the sponge out, and you can have an arbitrarily long mapping string. But cool cryptography stuff. All right, so let's go ahead and continue here. Here's the possible hash, right? Or line hash maybe, because we're hashing that line. And then we just need to check if, and then I'll jump immediately to the best solution here, strcmp of line, or not the line, but the line hash, and the hash that I'm looking for, this hash up here. If they match, then I've possibly found the password that I'm looking for. Right? So I will print out, printf possible match found, %s and the line, and we'll print out the line because the line is the original password that was used. The hash password is just going to be something that looks like this. Okay? All right. And then I don't want to print out every single line. I just want to print out that one possibility. All right. What was my any guesses? Oh, syntax error. strcmp. What's wrong? Oh, I have a. Do I? Oh, okay. Thank you. So it's going through 300,000 possible hashes here. Oh, it already ran. That's it. Okay. Okay. Done. Let's make sure. Oh, okay. It took a couple of seconds there, but really? All right. Let's do some debugging here. Let's go ahead and printf %s maps to %s and the line, and then line maps to line hash. All right, and then stop and make sure that these are all working. Right. Agudis maps to that. I'm pretty sure that this is SHA-1. I mean, it looks like SHA-1.
The prompt that you gave for the exercise says there's a hint that it's a dictionary word with a 4-digit number appended to it.
Darn it. All right, so good. There's my, what was it called again? There's my salt. There's a 4-digit number appended to it. So now I'm remembering this. This is a year ago that we did this exercise in class as well. And I remembered that, oh, it immediately did it. So, all right, I'm going to slow you down. And then I gave it over to everybody to do as an exercise for themselves. I'm going to slow you down by adding a 4-digit to the end of it, right? Appended, yeah. Okay, fine. So it's not going to be a line. Before we do the line hash, we'll append a 4-digit number, ... So line plus, or line is equal to line, not plus, but concatenated 1, 2, 3, 4. Let's find out. Because you said it was the most common. Oh, I don't want that. I don't want this anymore. Done. Okay, no, it wasn't 1, 2, 3, 4. 1, 2, 3, 5. Nope, it wasn't 1, 2, 3, 5. Okay, so how should I go about doing this, brute forcing it? Another loop, right? So for I equals 0, I is less than, what's one larger than any 4-digit number? 10,000, I plus plus. Bring all of this in. There we go. And instead of, I'll append I, except what's that going to do? When it's 0, will it append a 4-digit number? Nope, it'll append just 1, 0. When it's 1, it'll append 1 instead of 0001, right? So I could have maybe make the assumption that, okay, I'll go ahead and start out at 1,000 here. And now I'll automatically, as long as I chose a number that was 1,000 or greater, then this will be good. Let's see, it took 3 seconds before, and now I'm going 9,000 times more work. So 9,000 times 3 seconds is going to be 27,000 seconds. How long is that? 27,000 seconds, 2 hours. Yeah, 7.5 hours. And you see why adding just a simple salt is going to slow people down. Now, PHP is not the most performant language anyway. If you were going to actually do an attack like this, you would choose a much better language, a much faster language. You would certainly optimize all this stuff, and you would probably even want some sort of a hardware acceleration, like a GPU unit that could do hashes very quick. Custom-built hardware, maybe. I don't know if you were a NSA or some 3-letter organization, etc. But this is the basic idea. Let's stop there. And let's see. Last year was 2019. So, actually, if I'm remembering, let's only go with 8. Let's start at 1800 instead. 1908 is going to be my guess. 1, 2.
Set the endpoint lower as well.
Oh, good point. Well, last year, let's only go up to 2020. So, significance of 1908. Yeah, good. Not the last one, thankfully, from now. And certainly not going to be the last one ever, right? Okay, darn it. I don't remember. It's not done yet. But it was probably something that had some significance. Like, it wasn't just a random number that I think. but I don't have it in my notes of what I did. So this will be a guess, right? We could certainly try to do it with the original password, for example, like this. Let's go ahead and stop this and break this password with no appending here at all. So 0 up to 1, and then we won't append this at all. I'll go ahead and get rid of this. Right. So we should find password in the dictionary. There, possible match found password. Right. And that was immediate because we didn't have assault. We didn't have. This is why when you the systems force you to use non-dictionary words or a variety of characters because it gets way more complicated computationally to break passwords if you have more complex passwords. If you were actually going to do this in practice, by the way, use a tool called John the Ripper. Password cracker. Yep. You can download some, and it does. It's already optimized. It does a lot of things. It pulls in common rainbow tables. You can set it on a cluster so that you can, do it multi-thread. You can have all 8 threads, all 16 hyper threads on your computer, actually running password cracking over and over. Lots of different things that you can do. Right? Lots of very, very nice little thing that you can play with here. But of course, the first thing that you have to do is break into a system and get the hashed passwords. But once you've got that, then you've got a whole bunch of tools that you can use. Right. I swear, was it? Let's try 1908. Nope. Was it the year 2019? Nope. Was it the previous year?
You didn't switch
Nope.
the hashtag.
2000.
The one that was just password.
Oh, you're right. Thank you. Here's my password. There we go. 2016. Maybe that was it. Nope. Nope. 1908. Nope. What was it? Take it.
Maybe it was a computer history day.
PHP. 1995.
You got it.
Oh, there we go. Ah, there we go. Yay. 2000. It was the year that was used. And maquette. Oh, now I know the significance of that. Why I chose that word. Anybody know what a maquette is? Like it's a miniature design, like a playhouse, but for design, where you can design stuff. Like anyway, at the time, Microsoft had released maquette for the VR, and it's basically you can build stuff in VR. You can like draw. If you've ever seen Tilt Brush, you can draw in 3D space. With maquette, you can construct like a person. I'll go ahead and put a blob here, and then a blob here, and a blob here, and then collect them all together. And now I've got it's 3D modeling, but drawing it instead of using Maya or something to design 3D models. So maquette had just been released, maybe, and so I was thinking about it, and I used that. Okay, not a common word there. All right, let's see. Got 15 more minutes. Do we want any other demonstrations here? Otherwise, do you want this code in the PHP? There we go. All right. So the last thing I'm going to cover again is classes, but only syntactic stuff. For example, the one that I did last year here was and also from last semester, a class for airports. Not airports, but airport. So this is a class that models airports. Now you can put in, let me increase the size here. You can put in member variables. So tell me what an airport is made of. What do you mean by a terminal? Like think about Lincoln Airport. What's their name, right? So Lincoln Municipal Airport, I think. What else goes along with an airport? Oh, you're okay, planes? But then they fly away and they're no longer part of the airport. How do you identify an airport? So it's like a GPS ID, right? Or GPS ID, or GPS ID. Okay. And, well, if you're, whoa. All right, thank you. Thank you for that. And another useful thing might be latitude and longitude. Like what is Lincoln Municipal Airport GPS ID? I think it's probably LNK, is it? KLNK? Okay. Do you fly? No. Oh, flight sim. Okay, flight simulator stuff. So KLNK would be GPS. So they're whatever that's called, right? So there I've got an airport, right? I can create new airports here. I can go Lincoln is equal to airport. I'm calling basically a constructor here, and I can provide the Lincoln Municipal Airport. Is that the official name? And then their GPS ID was KLNK. And latitude, I don't know, 80 degrees north and 108 degrees west. Is that good? What is it? LNK, latitude, longitude. Lincoln Airport, latitude, longitude. Oh, I was close. 40 degrees north and 96 degrees west. So that wasn't very close. That's in Colorado. That would have been in Colorado or something. Right, there we go. So I can create that, and of course I can say try to print it. And this will run, but it probably won't do anything. Oh, no, it won't run. Uncaught error, unidentified function airport. Sorry. Let's see. I'm going to have to look at my notes. New. Yep. The new keyword is part of PHP. I forgot. I'm thinking JavaScript here. Object could not be converted to a string. Okay, so it's complaining here because if you just print it out, it's not going to do anything. So let's go ahead and print out, say, its name. Right? That's how you can access its name. And when I do that, I get, oh, nope, cannot access. Private property. Right? It's private. So I'll go ahead and make it public for a second here. And there. And once that gets done, come on. It is. Okay. Oh, duh. What am I doing? I haven't defined the constructor here yet. Right? So let me go ahead and change this back to private. In Java, how do you do constructors? Public, then the class name, airport, and then whatever you want to put in here. In PHP, you don't have that. Why? If you there's no function overloading, so you can't have more than one constructor. If there's ever a function called airport, then there's only one function called airport. And in PHP, they call them something different. Well, the constructor is called construct, not constructor. And there are two underscores right before it. These are called magic methods or magic functions. Several languages, Python has magic functions as well. And I don't know why they call them magic. They're not. They're just built into the language. It's just a name they use to distinguish that these are special functions that are built in and recognized already, and they have a particular purpose that you can't hijack them for your own purposes. So this is a constructor, and I can provide, say, a name, GPS ID, latitude, and longitude. And now there are two variables called name in scope here. The instance variable's name up here, and then the parameter variable up here. So if I just do something like name is equal to name, that's not going to have an effect. That's like int x is equal to x, right? So how do I distinguish between this name up here and the parameter name down here? This keyword, right? Now if this were Java, it would be this dot, right? But it's got to be different, so arrow. Even though there are no pointers, they stole that from C++ too. Right? And note here that there is no $sign right here. Even though all variables begin with a $sign, only the first one in a chain begins with a $sign. The subsequent one does not begin with a $sign. So this is setting the instance variable's name equal to the parameter variable's name. And then you can do that for the same for all of them. GPS ID is equal, or what am I doing? This GPS ID is equal to GPS ID, right? And that's what you can do the rest of them yourself. Each one of these is or can be made optional, and you can provide defaults in there as well, just like you can do with any function. And if I were to print this, I can do this now, and this will actually run, right? Oops, where? Line 10. Do this. Public construct, right? Oh, duh. Keep forgetting. Public function. All functions have to have function in front of them. Still not. It's private. So again, if I make it public again, then it should be able to print it. There we go. Lincoln Municipal Airport. This gets into, what is it called when you protect data? Kind of scoping. You're scoping it so that only the class can see it. You are encapsulating it. All right? So there's the name. By making it private, then you can't access it from outside the class. So what do you need to do? A function to do that, right? Public function get name. Return this name. And now you can do what we were doing before. You can print Lincoln's, and then you can invoke a function with the arrow key, or with the arrow operator, just as with the other stuff. Get name. And now it's still private. Okay, good. And there you go. You can use getters and setters. Right? I'm only going to do a few of them because I don't like typing. Right? Nobody likes typing. If I were to do this in Eclipse, I would go up and say, generate the code for me. Right? There's no generate code for me here, and so I'm not going to do it. What else? Oh, and then there's another magic function. The opposite of construct is what? Destruct. It's not necessary. Why is it not necessary? When you destroy something, you're cleaning up after yourself, right? That says memory management. Do you need to do memory management in PHP? Nope. Automatic garbage collection. So even though it supports it, no reason to use it. But there is another magic function, toString. And by the way, I am using lower camel casing here, but functions are case insensitive, so it's the same thing as this. But that's much more readable. And then you can return a formatted string here. Return, let's say, this name concatenated with space, and then concatenated with this GPS ID, and then concatenate that with a closing curly bracket. I don't like this. Right? How else could I do this without so much concatenate? Oh, okay. I was going to say printf at first, and then use %s, and then %s like this. But of course, the problem with that would be that it automatically prints it. It doesn't return a string of it. What does it return? Well, it doesn't return anything. It just prints it directly. sprintf, and returning that actually returns a string of that. And so now instead of getting the name, I can actually print Lincoln, and it will have we call it overloading, overwriting the toString method here, and now it will be happy about that. It prints the name and then the GPS ID formatted in parentheses here. Right? So the exact same functionality we're going to cover next week in Java, right, as a reminder. I'll show you how to build objects in Java and use your IDE to its fullest. so that you don't have to do all the boilerplate stuff of getters and setters and whatever. Right? And we'll build this exact same object in Java instead. And then on Thursday of next week, since again we go a little bit faster in this section, so that we can cover other stuff. We were talking about HTTP the other day, right? All right, so let's do that. We'll talk a little bit more about HTTP and how it works and how you can connect to stuff through HTTP. Either like how does this work under the hood? If I go to ESPN.com, then it went to HTTPS ESPN.com, right? I don't follow the NBA, so let's go to something better. MLB. There we go. Okay, I'll read that later. No, anyway, what happens under the hood when you're going to a website? You're making basically, at the lowest level, you are making a socket connection. I don't want this recorded. I don't want to be intellectual property or whatever. You're making a socket connection to a remote computer, and you are writing to a file. You're writing to a socket is a file. Remember, Unix, everything is a file. A file is a file. A directory is a file. A connection to another computer is also a file. It's just a socket that you open up, and then you start writing to it, and it magically gets sent over the wire. On the other end, they're reading from that file and seeing your request and seeing that it's a well-formatted HTTP request. We'll go through that protocol. We were talking about it the other day, and there's error codes for. I did look it up. 420 is an unofficial code used by, I think it was Twitter, and I think it was Max Your Chill. That was the message that Twitter used to give out. They would issue 420 in the event of you made too many requests, so they're going to block you with a 420 and say Max Your Chill, like settle down. Right? So 404 is forbidden, 403 is not hidden or whatever. Right? And we'll go over all that on next Thursday. Any questions? Remember, your first homework is due Friday of next week, so get a very, very good start on it right now. And a last reminder is, if you do not have a Java background, I would encourage you to do the homework one in Java. Or if you're kind of weak about it, or it's been 3 years since I did anything with Java, you might want to focus on Java because that's what we're going to use for the rest of the course. Okay? All right, next week.